Has anybody been numbering the pages of their notes? How many have we done so far? No? What we're going to look at now is adding mixed fractions. And with adding mixed fractions, we have two options for adding them. So I've written it down here as a method 1 and a method 2. This is like you have 3 1/3 chocolate bars, 3 full chocolate bars plus another third, and another whole chocolate bar plus a quarter. How many chocolate bars do you have? Now, one of the things in method 1, one of the things we've already done is we've already done improper fractions. So one method is to change your mixed numbers to improper fractions. If you would do that first, remember to change 3 1/3, you would have 10 over 3. 3 full ones would be like 9 pieces, plus the 1 extra piece that you have gives you 10 pieces. A method that people often do to figure that out is they go 3 times 3 is 9, thinking that 3 full chocolate bars in 3 pieces would have 9 full pieces, and then the extra 1/3 makes 10. 1 1/4, 1 full chocolate bar in this case would be 4 pieces, plus 1 more piece would be 5 out of 4. Once you've changed it to improper fractions, then the rules are exactly the same as before. You need a common denominator to add your fractions. So now we have to look at 3 and 4. What would the common denominator be? 12. Right before the fire drill, we had figured out that the common denominator was 12. So something you can show for work. And again, if you have a different colored pen, it's not bad to show this in a different color, that I need to multiply both of those by 4 to get my denominator 12. I need to multiply this one by 3 and this one by 3. So now this is going to be 40 over 12, and 5 times 3 is 15. 15 over 12. So if we change to improper fractions, we can use the same rules. Now that the pieces are the same size, 40 plus 15 is we would have 55 pieces out of 12. And in the end, we can write this number as a mixed fraction again. How many full 12s are there in 55? There's 4. 4 full 12s would make 12 plus 12 is 24, plus 12 is 36, plus 12 is 48. 4 full 12s would make 48. We have 55 pieces. So how many pieces would be left if we took out 48 of them? We'd have 7 left. So as a mixed fraction, the answer would be 4 7/12. Now, generally, I would say that most mathematicians would probably use method 1. But that doesn't mean that method 1 is necessarily easier. Okay? I actually like method 2 in a lot of ways because it deals with smaller numbers. So method 2 says we can add as mixed numbers, but instead of thinking of 3 1/3 as 3 1/3, we say, well, it's 3 plus another third, and 1 1/4 is 1 plus another quarter. And then we take the time to rearrange this so we have our whole numbers first and our fractions second. Then we'll add our whole numbers separate and our fractions separate. So what is 3 plus 1? Well, that's 4. Here we have to get a common denominator again, which we already know is 12. And I'll take out my different colored pen again. That means I have to multiply these ones by 4, these ones by 3. And we get 4 plus, now I have a common denominator here. I can add those fractions. 4 plus 3 is 7. 4 plus 7/12. And now we have a whole number and a proper fraction. And we can write our answer as a mixed fraction. Because 4 plus 7/12 is just 4 and 7/12. The nice thing about method 2 is that you never run into really big numbers. Some of the things that you might find mental math-wise as a little bit more challenging in method 1, changing this 55 out of 12 back to a mixed fraction, there could be a place there that might be tricky with your mental math. Adding them as mixed numbers tends to deal with smaller numbers all the way through. Sometimes when you add them as mixed numbers, you get an improper fraction on the fraction part, so we'll see how to deal with that as we do a couple of examples today as well. Everybody good on this page so far? I can go to the next one. So here we go. 3 2/5 plus 2 1/4. Again, I'll do both methods for a while, just so that we get a sense of it's important to know how to do both of them. They're going to help you in both ways. And then you can decide when you have a quiz or test which method you like the best. So method 1 is changing to an improper fraction. 3 whole numbers, if you're thinking of fifths, that would be 15 pieces plus 2 more pieces, 17 out of 5. Changing the 3 2/5 to a mixed number. Again, how did I do that? I thought if I have 3 wholes and things are divided into 5 pieces, those 3 wholes would be 5 plus 5 plus 5, 15 pieces. Plus, I have another 2/5 or another 2 pieces, giving me 17 out of 5. So 2 1/4, now I'm thinking quarters. I have 2 whole ones. That would be 8 pieces plus 1 more, 9 quarters. What's our common denominator going to be? Between 5 and 4. So again, we have to think about our times table. Is there a number in common? 20. Perfect. So these are both going to be 20. What do you need to multiply 5 by to get 20? By 4. And here you might need to take your calculator out. 4 times 17 is 68. Did you know if you wanted to do 4 times 17, you could still do it if you only knew up to your tens times table? Because 4 sevens is 28, and 4 tens is 40, and 17 is just a 10 and a 7 added together. So if I do 40 plus 28 added together, I get 68. And for the 4, what would you need to multiply this 4 by to get 20? By 5, so we have to go 9 times 5. Luckily, that's on our times table. 9 times 5, 45. Add these up. 68 plus 45 is 113. So we get 113 out of 20. How many full 20s are in 113? 5. Because 20, 40, 60, 80, 100, if I went one more, I'd go to 120, which would be too much. So I have 5 full 20s, which gets me to 100 pieces. How many pieces would I have left? So our final answer as a mixed fraction is 5 and 13/20. Method 2 says rewrite these as 3 plus 2/5 plus 2 plus 1/4 and then we can do 3 plus 2, add the numbers together, add the fractions together. Well, 3 plus 2 is 5. Again, we already know the common denominator is 20. We would need to multiply this one by 4 and this one by 5. Eight and 5. So this method, our numbers are much smaller, right? What was the biggest multiplication we've had to do so far? 4 times 5 compared to 4 times 17. And now when we add this, we get 5 plus 13/20 So when we're doing our math, I added the equal sign. Again, we work vertically to show each line is equal to the line above it, and we get our final answer as 5 and 13/20. For this one, I'm going to give you a scrap paper. I want you to try both methods. Okay, and see, I want you to come up with an answer for both methods. You did. Method 1. We'll get our improper fractions. So 3 times 6 is 18, plus 5 is 25 out of 6, plus 2 times 12 is 24, plus 5, 29 out of 12. Our common denominator is going to be 12. Multiplying this one by 2. Oops, did I say 23 and write 25? Yeah, I think I said 23 and wrote 25. Multiply that by 2 and this by 2. 46 out of 12 plus 29 out of 12. Add those together, you get 75 out of 12. How many full 12s? 6 full 12s. 12, 24, 36, 48, 60, 72. So that if 6 full 12s is 72 pieces, we would have 3 pieces left to make 75. So we get 6 and 3/12. And this 3/12 isn't in lowest terms. 6 and 1/4. Now, 12 was the lowest common denominator, but I saw people get the same answer by getting a common denominator of 24. So you're able to use any common denominator will work as long as you reduce your fraction in the end. Our numbers are always smaller if we find the lowest common denominator. Method number 2, 3 plus 5/6 plus 2 plus 5/12. This means we'll have 3 plus 2 plus 5/6 plus 5/12. 3 plus 2 is 5. Here our common denominator is 12 again, which means I'll multiply both of those by 2. And this is where something interesting happens in method 2. What kind of fraction is 15 over 12? It's an improper fraction. So you can change it. There's 1 full 12 and have 3 left over. You can change it to a mixed fraction. And since we're using method 2, 5 plus 1 and 3/12 is like saying 5 plus 1 plus 3/12. 5 plus 1 is 6. 3/12 would be 6 3/12, which again reduces to 6 1/4. Now both methods should give you the same answer because there's only one right answer, and it should match up. Is subtracting. I like method 1 better for subtracting. I'm going to show you both methods. I'm not sure it's less work. Method 1 is the same for subtracting. Method 2 is a little bit different for subtracting. So we'll look at what that exactly is. So method 1 is exactly the same, so that makes it easy. I change things to improper fractions. This will mean 16 pieces out of 5 minus 8, 11 pieces out of 4. My common denominator is 20. So here, you might use your calculator for 16 times 4 to get 64. 5 times 11, 55. 64 minus 55. How many numbers are there between 64 and 55? 9. Nine out of 20. For method 2, the reason method 2 is just a little bit different for subtracting is we have 3, oops, use black again. We have 3 1/5, and then we're subtracting 1 3/4, and this is where, if you're going to make a mistake, this is where we already made it. And it's really hard to see where we made the mistake. We made the mistake because are you subtracting 1 3/4, or are you subtracting 1 and then adding 3/4 back? You're subtracting 1 3/4. We're subtracting all of this. Mathematically, this would be in brackets, saying you're subtracting all of that. And one of the things that in mathematics, if you're subtracting 1 3/4, you are subtracting the 1, so I'm going to write this again, 3. We're subtracting the 1 and we're subtracting the 3/4. And this is where students make mistakes for subtracting in method 2. So what do we get? We get 3 minus 1 plus 1/5 minus 3/4. 3 minus 1 is easy, that's 2. Here, I get my common denominator again. And I would get 4 out of 20 minus 15 out of 20. If you're on your number line and you're at 4 and you subtract 15, what do you get? You're going to get a negative 11 out of 20. Ugh. And this is where method 2, maybe method 2 is more work, because that's a subtraction. If you're at the number 2, adding a negative is the same as subtracting. If you think about having one full piece of being 20 out of 20, and you subtract 11 out of those 20 pieces, you would be left with 9 out of 20. So with this method, you're almost thinking, oh, I have to subtract, so I'm going to take my 2, I'm going to go 1 plus 1 minus 11 out of 20, because I need to take one whole piece, which is 20 out of 20, subtract 11 out of 20, and I would have what went, something else went. Why do I get 1 and 9/20 on the right and only 9/20 on the left? Something went wrong. I don't see it right now. Okay, I'll look at that later. Well, the 2 is like 40 out of 20, right? So it just comes out as 29 out of 20, something. 3 1/5 minus 1 3/4. Maybe I made a mistake in the first method somewhere and I didn't recognize it. Yes, I see my mistake in method 1. My mistake in method 1 was I only have one piece out in front. 1 times 4 plus 3 is 7. So, sorry about that. Which means this would be a big eraser. This becomes $35, and 35 is 29, which is 1 9/20. And they match. So I thought that we had made a mistake in method 2. We actually made a mistake in method 1. The question is, if you made a mistake like I just did, and as we were doing the question before, I walked around and I saw some people had made mistakes in different places. Okay, I made a mistake right here. As a result, everything I did after that was wrong, and I got the wrong answer. And if I was checking my answer key, right, I'd be like, do I not understand this? Did I get it completely wrong? No. Everything we did after that was the right idea, but we had the wrong numbers. In mathematics, when you're doing a quiz or a test, if you have the right ideas but make a small mistake at the beginning, you'll usually get like 1.5 out of 2 or 2.5 out of 3. You only lose a small mark for a mistake like that. But as we go forward, we want to be checking things like this. Sometimes it's nice if you do 2 methods, like I did both methods, I'm like, that helped me realize we made a mistake somewhere. And we had to go back and try and find it. Okay, a couple more subtracting ones. Again, get you to try.